Hello students, how are you? I hope you all are doing fine. No? So today we will discuss the next part of the lesson, motion, that is going to be part 4 of the video. Till now we have discussed lots of things about the lesson motion, right? First we have started from some physical quantities like scalar quantity, vector quantity, right? Then we have moved toward some concept about rate of change of motion, okay? Then we have discussed about speed, okay? Then we have discussed about the velocity, which is a vector quantity. Then we have discussed about the acceleration. Okay. And in the last part, we have actually solved some problems. I hope you all have just understood the problems. If you find any kind of difficulties in understanding the problems, just tell me in my comment section. Okay. By the way, I will today announce the winner's name of that quiz competition. Okay. And along with that, I will also include here one more quiz competition. I will always include this quiz competition in my every video. So go through my videos, okay, and participate in it. You will always learn something new. Okay. And that quiz competition actually make that class interesting one, right now. So today we'll move towards this part. Okay, see, till now we have understood the concept of velocity, acceleration, and speed. Okay, we have actually understood the definition of velocity, speed, and time, acceleration. Okay, both of the quantities, or these three actually quantities, depend on what? Time. That means with time they actually changes. Clear? Now we will see, or today we will actually observe how the velocity, acceleration, and speed, or you can say reverse the speed, velocity, and acceleration changes with time, depending on two motions, that is a uniform motion and non-uniform motion. Clear? And from the concept of graph, you all know what is graph. Okay, for that you have maybe got the Cartesian coordinates, right? X-axis, y-axis. Okay, see, graph means nothing but whenever we actually discuss, right, certain things, like whenever, now just take a recent example. Now corona is everywhere, right? Every city there is corona, right? So whenever you just click the news, okay, they will show how much people are getting infected day by day. Okay, maybe in 2020 there's going to be a graph, then 2021 there's going to be a graph. If it again comes next year, then there's in 2022 there's again going to be a graph. So that is kind of graph. Okay, so with the help of those kind of graphs, we will actually observe how the motion of an object actually varies depending on if that motion is uniform motion and non-uniform motion. Okay, clear now? So that today's topic is graphical representation of motion, right? And before starting the main parts, I just want to tell you that there are three types of graphs going to be in here. Okay, first graph is going to be position time graph. Position time graph, that is nothing but the xt graph. Okay, xt graph. Okay, now the next one is velocity time graph. Velocity time graph. Okay, that is nothing but the vt graph. Okay, now third one is acceleration time graph. In your NCERT book, this acceleration time graph is not actually properly mentioned, but we should know that acceleration time graph, how it actually varies. Okay, clear now, students? So depending on the motions, we will just cover three types of graphs. Okay, and before starting this, one thing we should actually consider, or one thing that we should actually know, in this position time graph, and this position time graph is also known as distance and time graph. Okay, in your NCERT book it is written as a distance time graph, so don't get confused about that. Okay, so because distance is always related with what? Change of position, that's why you can say that this is a position time graph. Clear? Nothing to be actually worried. So see here, position, velocity, and acceleration. Okay, this position can also change, that velocity can also change, and acceleration can also change depending on which? The time. That means what? Time is going to be what? Independent quantities, because we depend on time, these three will change, but time will remain constant. It constant means what? Time also changes, but it is independent. It depends on nothing. Time is free. Okay, time doesn't depend on us. We depend on time. Okay, time doesn't actually move according to us. We should move always according to time. That's why we should not actually waste any time. Okay, so then just give your attention to the video. Don't waste your time. Nah? Okay, now we will observe this kind of graphs. What is going to happen when there is going to be uniform motion and non-uniform motion? First, we will start from one motion. What is there? Rest motion. Okay. We'll observe what is going to be there when it is in the motion is in rest. Okay, then we'll move towards the uniform, then we'll get the non-uniform motion. Okay, step by step. Okay, first I will erase this part. Our first motion is going to be the rest motion. Rest motion, right? In case of rest motion, what actually happens? What actually happens? The distance, okay, remains same. Okay, if an particle or an object, it is in A position. Okay. If it is in rest, it will always be in rest. It is not going to move to this position, right? It will always be here. Okay. Now, if we have to put this in graph, how it will actually look like? Just see. Okay. This is the graph. Okay. So in the always x-axis, if it's an x-axis, it is always time in second. Or distance will be here. Oh, by the way, this first one is going to be distance, or you can say position time graph. I have not actually mentioned. Okay, this is the distance time graph for the rest motion. Clear? This is the distance. As I told you, if a particle or an object at rest at a certain time, if the time changes, it will be always on rest because the motion is rest. That means what? If I consider this is the 0, this is 10 second, this is 20 second, this is 30 second, this is 40 second. Enough. This is the 10 meter, okay, 20 meter, 30 meter, 40 meter, 50 meter. Distance is in meter. Okay. Now I will consider at 0 second, it was in A. Okay. Right now, clear? Again, at 10 second, it will always be here at a 30 meter. Okay. At 20 second, it is always be here. At 30 second, it is again will be here. Right? At 40 second, it will always be here. That means what? Time maybe changes. The position is what? At 30 second. Okay. If it was be here, it was be here. Then it is not like that, no? Its position doesn't changes. Okay. That means what? It is in 30 meter. Understood? If I draw a line through these points, okay, this is the distance time graph for the rest motion. Quite simple. Okay, quite simple. Nothing to be actually get confused here. Quite simple, no? Now we'll move towards the velocity time graph. Okay, if you want to draw this, or if you should draw this, you just open your book or copy, just draw this down. Okay, and this rest motion is not in a copy, but you may get question about this rest motion. Okay, and don't think because you are in class 10, you are going to have a board exam, and never think that you will only get questions from your book. You are going to get questions from your concept. Okay, not out of concept. Okay, you know the concept of rest motion. Okay, understood now? So just draw this down, and I will move towards the velocity time graph. Okay, velocity time graph. Now we'll move towards the velocity time graph. It is again simple. Again, I will draw two axes. Okay, in this direction, it is always time. Second, now it will be here velocity. Okay, it will be meter per second because I have considered second, right? So again, I will give some reading 10, 20, 30, 40, 50. Again here 10, 20, 30, 40, right? It is a 0. See, it is a what? Motion, rest motion. In rest motion, is there any velocity with time changes? No, because see, consider me as an object. Okay, I am standing here. Okay, if I am standing or if I am considered to be at rest, I am going to be having any velocity because velocity means what? Net displacement by or the change of position or change of displacement or displacement by time. Displacement is nothing but what? Change of positions, but it has a direction. Okay, that's why it is a displacement. Simple. But if there is no change in position, there is going to be no velocity. Clear? Right now? So that means how can we actually represent in a graph? In 0 second, it will be in 0 value. It will have 0 value because it is the velocity. That means if it is not going like that, that means it has 0 velocity. At 10 second, it is again going to have a 0 velocity. At 20 second, it is again going to have a 0 velocity because this is the curve where the velocity is not changing, right? Only the time is changing, okay? At 30, it is going to be here. At 40, it is going to be here. At 50, it is going to be here. That means what you can say? With time, velocity is not changing. Velocity at rest because the object is at rest. That means velocity is going to be 0 meter per second, okay? In all this case, it is going to be 0 meter per second. It is going to be 0 meter per second. It is going to be 0 meter per second, right? It is going to be also 0 meter per second. And even it is going to be have a value of 0 meter per second. Value of velocity. Understood now? Quite simple. Nothing to be actually get confused, okay? See here. Now, we'll move to the next acceleration time graph, okay? If I draw the acceleration time graph here, okay? In one page, it is going to be clear. It is going to be acceleration time graph. Okay, acceleration time graph. I will now consider here time represented by time t. It is going to be acceleration. The unit is going to be meter per second square. Okay. See, simple concept is going to be there. If there is no velocity, okay, is there going to be any kind of acceleration? No, no, because acceleration's definition is what? The change of velocity. Okay. If there is no velocity, is there going to be any change in velocity? Obviously not. So if I give some readings 10, 20, 30 like that, and if I get another reading 10, 20, and 30 like that, so what will happen? The same thing is going to be here. With time, acceleration is not going to change. Okay, acceleration is going to be like that. Okay, here in 0 second, acceleration is going to be what? Here a, it is going to a, again it is going to be a, it is going to be a. That means what? These all values are having some acceleration. Sorry, 0 accelerations with change of time. Time is changing. Time is not never can be rest. Time always changes. Okay, as I said, time always changes. There is almost change of 5 to 6 seconds. It does take me to say a word, time always changes. That means what? Time cannot be at rest, but velocity, acceleration and positions can be at rest or can be zero. Clear? Done? This is the concept about the rest motion. Okay. Now we'll move towards, depending on the same concept. Okay. I think now you have understood the concept of graph. How graphically this actually represent. See, now we are dealing with the physics. Okay. You now have to deal with graphs too, because some student may think or may thinking that I will pursue physics in higher level or to higher level. So if you are thinking like that, okay, if you just trying to be in engineering department, nothing like something like that, you are going to need this graph concept. Okay, so always try to give some or take some concept about this graph, so be attentive. Our next thing is going to be uniform motion, right? Uniform motion. Okay, what does it mean by uniform motion? Okay, I have clearer concept. Uniform motion means with equal interval, okay, distance traveled is equal. That means what? Speed is constant, right? If we consider an object, it is at A, okay, after 10 seconds it is going to be at B, after 10 seconds it is going to be at C, okay. That means that if that uniform motion will be, if you have to cover 2 meters here, it has to cover 2 meters here, then it is going to be a uniform motion. Okay, now we will actually apply this to the distance time graph, position time graph, velocity time graph and acceleration time graph. Okay, now we'll observe that. Okay, see what is going to happen here. First we will observe the distance time, or you can say position time graph, that is the xt graph, right? X is mean by distance or time, you can just consider it. Okay, here in this direction it is going to be time, okay, in second. Here it is going to be what? Distance in meter. Then it will be some kind of linking up. Okay, now I will give some values: 10, 20, 30, 40, 50. Okay, same kind of values I will give here too: 10, 20, 30, 40. One more value, 50. Look closely. What I've said, that with time, okay, distance going to have an equal interval. Okay, that means if at 0 second it will be always at 0. Okay, if at 10 second it has 10 meter, at 20 meter there is a distance, change of distance will be also 10 meter. That means what we can say, if at 10 meter it should have a value of 10 second, it will value of 10 meter. Again at 20 meter it should have the value of how much? 20 meter, because what? The interval of distance should also be 10, right? At 30 meter it will have a value of 30 meter. Okay, at 40 second it is going to be have a value of 40 meter. If 50 second it is going to have a value of, okay, 50 meter. If you draw a line, okay, this is the line which actually representing the distance time graph or the uniform motion. Okay, that means what we are getting understood, that speed is going to be same, okay, in every case, or it does change of motion. Clear concept, right? This is the thing. Now how to actually understood the definition of speed through this graph. See, what we know, the definition of the speed as distance by time. Okay, so if I take 2 points or 2 times, okay, this position and this position, consider as the A position and the B position. Okay, it is having, I will draw a proper line. Okay, this is T1, okay, and this is going to be what? T2. Okay, this is the T1. I just draw a normal here. Again, I will draw one normal from here. Okay, this is the distance. Okay, I can say S1. Okay, and again, oh, sorry, I have gone a little bit upward. I will draw one more line here. Okay, just consider it. This is the S2. S2 is meant for distance. Okay, nothing but. You should actually, I will just represent the speed as by phi. Okay, okay. See now, what is going to happen? Okay, this amount of value, or this line will give us the what? Change of position or change of distance, right? It will have a value of S2 minus S1, right or wrong? Right now, because it is at the position S1, S2, this is the position S1, this value will be S2 minus S1, right? That means this much of distance is actually covered, okay, in changing from time T1 to T2, right? And what is the change of time? T2 to T1. Right now, if we have to write from this graph, what will write? What is the distance will be here? S2 minus S1, right? And what will be the change of time, or what is the time taken? T2 minus T1. Simple concept. Okay. Now, this is a value of speed. Now, how we will actually consider, or how we will now actually understood the higher speed or lower speed? If I draw one more graph, like here. Okay, see what is it, how it will actually happen. I will consider a point, not this line actually. Wait for a minute, it will be more actually understandable for you if I draw a line a little bit like that. Okay, see now here, if I again draw this line till here, again if I draw this line here, what is going to happen? This is going to be the 1 point, okay, and for that this is going to be 1 point. It is clearly actually observable, okay. This is going to be a new line, okay, and this is going to be one more new line, okay. Now what do you think, in both the two lines, which line going to have a higher amount of speed? Simply this line, because it has a higher amount of distance, okay. Time distance or time taken is same, okay. The distance travel is higher, okay. If it is constant and it is changing, okay, for a line whose value is higher, whose value have a higher amount of distance change, will have a what? Higher velocity. So this line is going to have a higher velocity compared to this line, right? That means there should be a concept, okay, there is a concept that is known as slope, okay. Slope is nothing but making an angle with a base, okay. Since I'm standing in plane, I'm making an angle 0 degree with the ground, okay. If I have to climb up the stairs, that is making some angle with the base, right? This is the angle. Simple cases here. This line have a maybe angle of 30 degree, but this line will have a making angle of 60 degree or 45 degree, how much you can say, okay. So there is a sense of angle. Which line is going to have a higher amount of angle or higher amount of slope, that line is going to have a higher amount of velocity. Concept clear, right? Now we'll move towards the velocity time graph, okay. If you want to just draw it down, draw it properly, okay. And this concept about this slope is not in book, okay, but you should know that. Simple concept. Now we will move towards the velocity time graph, okay. We will check velocity time graph. That is nothing but the VT graph, okay. We will observe what is going to happen. Simple case, T in second, P in meter per second, right? Going to have values like 10, 20, 30, 40, 50. Again going to have value 10, 20, 30, 40, 50. Okay, and this is the 0. See, what does this uniform motion means? That speed and velocity going to have the same value in equal interval of time. Okay, that velocity will also be constant. Okay, velocity is not going to be changed. If the velocity changes in uniform, so it is not going to be a uniform motion. It is going to be non-uniform motion. Then we are going to have a concept of acceleration if the velocity changes. Right now, what is the definition? What was the definition of acceleration? Change of velocity with time. But if it is a uniform motion, there should not be no change in velocity, but time should always change, right? That means what is going to happen if at 0 second, if it is a value of motion means what? It is in always motion. So I will consider that it is a motion. So at the first 10 second, it is going to be a value of 30 meter per second. At next 1 second, it is going to be 30 meter per second. At 30 meter per second, it is going to be one more velocity, 30 meter per second. At 40 second, it is going to be 40 meter per second. At 50 second, it is going to be a value of 30 meter per second. That means the velocity is still constant. Clear? So if I draw a line passing through all these points, it is actually not getting passed through the point like this, right? These are the points, okay? These are the points. These are the values of points. Okay, you can give a value of P, V, V because all the values are velocities are equal, right? But times are different, right? Now we have understood the concept of velocity time graph. Now, what if we need to calculate the distance or displacement, okay, through this amount of this change of time? Okay, for that we will draw one normal from here. Okay, one normal from here. Let's write some name A, B, C, D. This is what type of geometry? Rectangle, right? So this amount of area, okay, this amount of area is going to give us the distance or displacement. Okay, so how to calculate this amount of graph, or how to calculate this actually displacement or distance? See, we have a formula that velocity is nothing but displacement by time. Okay, now if you need to calculate displacement, what will happen? These two are going to be multiplied. Okay? I have just determined the denoted by the d, the displacement. It is going to be velocity into time, right? Now how to get the velocity? This is the amount of velocity, right? In y direction is what? Y direction, in the y direction we have a value of velocity. So this AD will give us value how much? 30 meter per second. Okay, and this AB is what? Time, right? This AB is going to have a value how much? 50 minus 10, 40 meter per second. Sorry, 40 second. Not how much? How can it be 40? 40 second, right? Now, since this is the area, right? This is the area, no? So the area of this rectangle is going to give us what? Displacement. So how we'll write? The displacement is going to be area of A, B, C, D rectangle. So what will be the area? Area, what is the formula for area of rectangle? Length into breadth, right? Now what is the length here? AD, right? And what is the area of the actually what is the base? AB, right? AD is nothing but 30, and what is the AB? 40, and it will be in meter. 30 into 40 is going to be 1200 meter, right? AD has a value of 30 meter and AB has a value of 40 second, right? This has a value of 40 meter per second and 30 meter per second. From that second, and from this second is going to be cancelled. Only meter is going to be here. Okay, so this is the thing. We have understood that how we can actually calculate, or how we can actually plot velocity time graph with this graph. Okay, now if you want to write this down, just write it down properly. Just pause the video and write it down. Our next topic is going to be non-uniform motion. Non-uniform motion. Okay, in case of non-uniform motion, what actually happens? The distance traveled is going to be different but in equivalent interval of time. Okay, and once the concept of non-uniform motion comes, okay, that means what? The velocity and speed is not going to be same throughout the journey. That means if there is a change in velocity, okay, so what can be there? Acceleration. Okay, but in non-uniform motion, since going to be acceleration is there, but again it has a two part. One is uniform acceleration and non-uniform acceleration. Okay, because it mainly going to lead us to acceleration, right? So first there is going to be what? Uniform acceleration in short, and it's going to be non-uniform acceleration. Again, this non-uniform acceleration, okay, what is going to happen if the acceleration decrease? That is nothing but what? If the velocity decrease from high amount to low amount, it is going to be what? Retardation, right? Right now, so this non-uniform acceleration leads us to what? Retardation. All these things are linked up. Okay, now first we'll see in case of non-uniform motion. Okay, under the non-uniform motion, what is going to happen in case of uniform acceleration? Okay, so it is going to be one more branch, and that branch is nothing but what? Uniform acceleration. Okay, under this graph, under the acceleration, first we will check the velocity time graph. Okay, first we will say velocity time graph. It's nothing going to be there. Velocity time graph. Okay, velocity time graph Vt. Right. See, uniform acceleration means what? Acceleration, like it's similar to uniform velocity. What happens in case of uniform velocity? The velocity remains constant, right? But since it is uniform acceleration means what? That acceleration is going to be same, right? And how the acceleration will going to be same if the time is constant? The velocity should have changed an equivalent interval like this. If the acceleration is 2 meter per second square, okay, it is given, okay, and it is the uniform acceleration at 0 second. It is going to be 0 meter per second square, right? At first 1 second, it will have a value of 2 meter per second. Sorry, this is one velocity change, right? At 2 meter per second, it will have a value of 2 meter per second, right? At 3 meter per second, 6 meter per second. Now, if you want to calculate the acceleration from here, how will you calculate? First, we will change the velocity. 4 minus 2 is going to be what? 2, and 2 minus 1 means what? 1. If you divide 2 by 1, what is going to get? 2 meter per second square. Same thing is going to be here. That means what you can say? The velocity remains, or the velocity is continuously and changing with time in an equal time and proportionally, right? That means which 1 second it is 2 meter per second. At 2 second it is the same, right? So it's like that. Now we will actually understand this with a graph, proper graph. Okay, just look here. This is time, this is velocity. Okay, meter per second, and it's going to be in second. Okay, give some reading 1, 2, 3, 4, 5, and again give some reading like 2, 4, 6, 8. We have some values, right? At 0, it will be at 0, right? Again, at 1 second, it is going to be a value of 2 meter per second. Okay, now at 2 seconds, it is going to be a value of 4 meter per second. At 3, it is going to be a value of 6 meter per second. At 4, it is going to be a value of 8 meter per second. So if I draw a line passing through these points, okay, straight line. This is passing through the center, right? Now this is the concept of a velocity time graph. Now again, the distance traveled with this acceleration we have to find out, right? So for that, what will you do? Same thing we'll actually do. We'll draw a line from here. We'll again draw a line from here. Okay, first I will draw this line and draw this line. Okay, so we have got what? This amount of area, right? So if we need to find out the distance traveled here if I give name some name A, B, C, D and E. Okay, so if we need to calculate the distance or displacement, this much of area is going to give us the what? Distance, right? So we'll check, right? We'll check. So here, if you clearly look, okay, if you clearly look, there is one rectangle, right, and one triangle, right? One triangle, right? Now, so the area will give us what? The distance. So what will be the area here? Area of triangle ABE plus area of rectangle ABCD, right? Clear? This AB is going to have a value of 3 to what means 1 second or 1 magnitude, only consider the magnitude 1, right? And this BE, okay, we have to calculate the BE. How to calculate the BE? If you minus the CE, okay, that BE will be EC minus BC. Okay, EC has a value of how much? 6, and BC has a value of 4. That means BE is going to have 2. That means BC has going to have a value of 2. Clear, right? So the area of triangle is going to be half of AB into BE. That means half of base into perpendicular plus the area of rectangle is same. The AD, again AD has a value of how much? AD is a value of 4, right? Plus, that means we can say AD into what? DC. DC is equal to AB. So what we can write in case here, if you put the magnitude, AB is 1, what is BE? BE is 2 plus what is AD? AD is 4. And what is DC? DC is equal to AB. AB is going to have a value of 1. If we cut this out, what is going to get? 1 plus 4, that is 5. That means that the area actually give us meter. That means the distance, right? Actually it is a distance actually. Distance give us the value of 5 meter. Clear the concept? This is the velocity time graph, and with this graph, you can actually calculate the distance using the concept of geometry and using the concept of area of triangle and area of rectangle. Okay, once I am just teaching you these things, along with that, at the same time, you should open your book. Okay, sometimes what happens, you may not understand my letters too. Okay, it is better if you are just continuously using your book, watching my videos. Okay, it will be proper for you. Okay, I am just telling you for your benefits. Okay, now we will move towards the acceleration time graph. Okay, we have convert or clear the concept of velocity time graph. Now we'll move towards the acceleration time graph. Okay. So what I will actually look, what is going to be here in case of uniform acceleration, right? So next is going to be our acceleration time graph. I just write it shortly, A for acceleration and T for time. Okay, now we will check. Okay, here it is going to be acceleration, it is going to be of unit of meter per second square. Again, in this direction it is have a T, that means time, it is going to be a value of second. Simple concept, right? Now we have considered that uniform acceleration as form how much? 2 meter per second square. That means uniform acceleration means that acceleration is going to be same throughout the journey. Okay, and if with the change of time. Simple concept, it's like uniform velocity, right? It is the 0, it is the 10, it is the 20, it is the 30, 40. Enough. Yes, it is. These all rings are in second. Clear. Now I will actually give here some value of acceleration like 1, okay, 2, 3, 4. I will change the uniform velocity as 4. Then until the graph will be proper. Okay, 5 and 6. So since the velocity is or acceleration is actually uniform, at the first change of time, that means at 10 seconds, it is going to have a value of 4 meter per second square. Right, at 20 seconds, it is going to have a value of 4 meter per second square. At 30, it is going to have 4 meter per second square, and at 40, it is going to have a value of 4 meter per second square. Again, if I draw a line, okay, this line will represent the acceleration time graph. Again, if you need to calculate the graph, okay, the distance or displacement, it is quite simple to the velocity time graph. You just draw it by yourself and just solve it by yourself and give me and just write it. You know, don't need to give me answers in my comment section. You just write it down in your copy and just check what is going to be the displacement. Okay. Okay. This is going to be a displacement. Again, you can actually tell me what is going to be a displacement in my comment section. But this is not a quiz combination question. Okay. Those who want to give me the answer in my comment section about this displacement using the concept of again same rectangle calculate the area inside this rectangle, and that area will give you the displacement. Clear? Na? Quite simple thing. It is the distance, displacement and time. With that, we actually understood the concept of AT graph, that is the acceleration time graph. Okay, how it actually changes. Uniform acceleration means acceleration is going to be same throughout the change of time. Clear? Now we will see the position time graph. Okay, just if you want to write it down, just note it down properly. Okay. Now we will move towards the next one of the non-uniform motion, or the last one for the non-uniform motion, that is going to be the xt, or the position time graph. Okay, see, this thing is going to be same for everyone. This is the x, it will be in meter. Okay, this is the time, it is going to be in second. Right now it is the position time graph. Okay, we will observe that. We will consider the acceleration as 2 meters per second square. Since it is a uniform acceleration, what does this give? The concept of, right, velocity 1, v2 is going to be 2 meters per second. Right, v3 gives us the value of 4 meters per second. Right, v4 gives us the value of 5 meters per second. And these velocities give us the concept of that 1 second it has a value of what? 2. At next 1 second it has a value of change of position of 4 meters. Right? At the next 1 second it has a change of position of 5 meters. Right? The distance travel is not continuous, it is actually changing. Right? So in that case, so the graph will somehow have a value of look like that. That means if I draw the line, that line will somewhat look like this. Since this is an accelerated motion, okay, it is quite simple. You don't need to write these things. You can understand by the concept. Since it is an accelerated motion, though it is a uniform motion or a uniform accelerated motion, it is accelerated. Na? Accelerated means what? That position will not be constant or continuously change with time. It will change, but in different amount, right? Understood, na? But in case of that, actually, we have understood the uniform motion. Okay, what did happen? The change in position with time was actually continuous or in proportion. But here the change of position is not going to be proportion. But here the velocity change is going to be at proportion. Understood, na? This is the concept about the position time graph. Okay. If you want to have any doubt, ask me about the uniform acceleration, the position time graph. If you get any kind of difficulty, because this kind of graph is quite new to you, na? So if you get any kind of difficulty, but I think there's no actually, you shouldn't have any kind of difficulty because quite simple. Just look here. The velocity is going to be continuous change, na? From 0 to 2, again 0 to 4, again 0 to 5. Okay, do not think from 2 to 4. Right? Not like that. 0 to 2, then 0 to 4, then 0 to 5. That means what? First it changes the distance of 2 meters, then it changes the distance to 4 meters, then it again changes to distance 5 meters. 2, 4 and 5 is not actually proper, or not continuous, not proportion. Okay, in time. So the graph will look like that. Okay, clear. Okay. Again, if you want to understand this position time graph for the uniform acceleration or non-uniform motion, just look clearly here. What is actually written here? Non-uniform motion. Non-uniform motion means what? That speed is going to be what? Different, right? So that distance and time graph actually gives us the what? Speed, right? Because distance by time is nothing but what? Speed. So what we can say, if it is a 1 second, 2 second, 3 second, 4 second, right? If it is 10 meter to 20 meter, 30 meter, 40 meter, that non-uniform motion is that speed is not going to be same in every moment, right? Though the acceleration is same. Right, at 1 second maybe it is at a 10 meter, at 2 second maybe it is at a maybe of 15 meter, at 3 second it is maybe at a 30 meter, right? 10 to 15 it is a difference of 5, and 15 to 30 it is a difference of 15. That means what? The differences are like not same. 0, then 5, then 15, then at maybe at 4 it is at a 40. That means 30 again 10, right? So these intervals are not actually equal. Okay, that's why it is not uniform motion. So that's why the graph will be look like here. It is not going to be a straight line, right? Straight line means what? It is a continuous change with time. Clear, na? So now we have actually understood the concept of uniform acceleration. Now we will look towards the non-uniform acceleration. Okay. So what actually happens in case of a non-uniform acceleration? Non-uniform acceleration leads us to the concept of retardation, right? So what you can write? Non-uniform acceleration. We will see how it can be retardation. Okay. Non-uniform acceleration. So it is here time in second. I will consider velocity as meter per second. How it is a retardation. Okay, we'll check. If it is a velocity time graph with non-uniform acceleration, okay, and retardation, the velocity will constantly decrease, okay, with change of time. 10, 20, 30, 40, 50, 10, 20, 30, 40, 50, 60. So this is the main graph for the non-uniform acceleration. That means, see, retardation means what? If u is the value of 60 meter, per second square, initial speed or initial velocity, and v is the 40 meter per second square, meter per second, sorry. So what is the change of velocity? V minus u, that is going to be minus 20. That means it is decreasing. Minus 20 means nothing but it is in the negative direction. No, though it is in the negative direction means what? It is in the opposite direction. Okay, it is the acceleration is going to be decreased. I told you in the last class that what does this negative sign means? That negative sign means nothing but the retardation, and this is the concept of retardation. Right, from the higher velocity is moving towards the lower velocity, but with the change of time. Okay, this is the concept of non-uniform acceleration. Right? If we need to understand, okay, in one graph, and that graph is nothing but velocity time graph, how the velocity and acceleration is going to change in velocity time graph. Okay, we'll observe. Okay, this in this y-axis we're going to get the velocity as meter per second. In this direction we will actually observe the time in second. Right? First we will consider the uniform motion or uniform velocity. Right? Uniform velocity and non-uniform motion. In uniform motion, what happens? The velocity changes continuously with time. Right? So this is the positive part, the acceleration. Right? So again, at certain moment velocity remains constant. Right now, and after at a certain thing, the velocity again decrease. Is the velocity is negative, and it is going to negative acceleration. And negative acceleration is nothing but what? Retardation. Okay, this is the concept about the velocity time graph regarding the uniform motion and non-uniform motion, right? So if you need to find out the distance or displacement, you just need to find out the area inside this graphics or graphical representation or geometrical representation. This is nothing but a what? Trapezium, right? If you want to need to find the displacement inside this graph, you just need to find out the area under this geometry. Just find out the area of the trapezium. Okay, with the proper marking, you can just you will be able to actually understand the concept of displacement. Clear? Okay, this is the time to find out the winner's name. Okay, who gave me the correct answer about my last question? My question was between these two velocities, right? 30 meter per second and 30 km per hour, which is going to have a highest amount of or higher amount of velocity. Okay, first we will check what is going to be the here. See, many students gave me answers by converting this 30 meter per second to kilometer per hour. It is actually quite hard because we have to convert this second to hour. Okay, it is always better if we convert the higher to lower. That means it is in kilometer. If we convert this to meter, it is going to be easy, right? So we'll do that. So 30 is going to be 100 meter because 1 kilometer is in 100 meter. So in our it is 3600 second. We'll just cancel out the zeros. It is going to be there 300. It is going to be 36 meter per second. It is clearly visible. If we do this, we are going to get a single digit quantity of this conversion. First, we will simplify. If we divide it by 3, it is going to be 100. It is going to be 12 meter per second. It is going to be almost 8.33 meter per second. Almost 8.33 meter per second. See, this is 30 meter per second. And it is 8.33 meter per second. So, which is greater? Obviously, this one. So, this correct answer is 30 meter per second. And who gave me the correct answers? Just congratulations to all of you. Okay. So just wait for me. I'll just announce the names. Okay. First, give me correct answer Diptangsu Oleman. Okay. After that, give me correct answer Tamanna Kashyap. Okay. Tamanna Kashyap, give me correct answer. She do it like this way. Okay. She just converted 30 km per hour to just meter per second. Okay. Again, the next one is Rishikesh Boro. Next one is Anur Dekha. After that, Amanjita Rahman. Okay, she actually converted this to kilometer per hour. It is a little bit different. Okay, but it is also correct. Don't worry about that. After that, give me correct answer Hrithik Chaudhary. After that, Rakibul Hussain. Okay, he did it like this way. And after that, Analip Kashyap. After that, Bandita Kalit Saikia. Next, after that, her name is Tamanna Kashyap. One more Tamanna Kashyap. She gave me the correct answer too. And after that, Pakiza Begum. She again give the correct answer. After that, Salim. He gave me correct answer. Okay. After that, Mehbis Raihan, he gave me the correct answer. After that, Joseph Sen, he also gave me the correct answer. So after that, Nikita Kalita gave me correct answer. After that, SK Intifa Khatun, she again gave the correct answer. After that, Dutikana Devi, she again gave me the correct answer. After that, Pritam Kashyap also gave me the correct answer. Tamanna Aziz gave me the correct answer. Again, one more Tamanna. This is 3 Tamanna. Again, next one is Saurabh Kalita. He again gave me the correct answer. So, do you know what? Every student gave me the correct answer. That means you have understood the concept of change in unit. You have understood the concept of meter per second to kilometer per hour. Again, I can consider that you have understood the concept of speed, velocity, and time. Okay. So, very much congratulations to all of you. Okay, always be like that, always keep participating. Okay, along with the views, right, how much views I have actually got, in that comparison that actual ratio is less, but still not a big issue. Those who have participated, just big congratulations to all of you. Okay, just try to find out the answers, use your brains. Okay, always try to keep your brain active. Okay, it will help you in higher level when you go to higher classes like higher secondary, BSc, MSc. If you want to do BTech, if you want to do MBBS, it is going to help you. Now we will move towards our today's quiz competition question. Okay, quiz competition. Okay, we will see what is going to be our today's quiz competition question. Simple question, use some concept. Okay, we have till now in this class we have to discuss the concept about the graphs. Okay, use the concept of graph first. Okay, just believe me, those students who will watch the video properly without skipping, I can understand lots of students are skipping those videos because these are lengthy. Consider this as not your video. Okay, consider this is your class because you are going to have a class of almost 45 minutes. I am making video of 45 minutes. Okay, I am not making more than that video. Okay, just try to give some attention to the videos. You watch properly. If you have any kind of doubts, just ask me. Okay, this is our today's quiz competition. Okay, just watch properly. Okay, here in this direction, it is the time in second. It is going to have a velocity. Okay, mean meter per second, right? If I draw a line like that, okay, like that. So give some reading: 10, 20, 30, 40, 50, and 60. Again, I give some below 10, 20, 30, 40, 50, 60. Always remember, this 10 to 60 is a value of 10 meter per second, 20 meter per second, like that. And in this direction, it is 10 second, 20 second, 30 second, 40 second, 50 second, 60 second. It's like that. Now, my question is, give the physical meaning, okay, of this graph. Okay, physical meaning means what this graph is actually making, okay, meaning. Okay, what this graph actually represents. I need this answer. Okay, properly give me the correct answer. Okay, in a small 1 to 2 line you can write. You don't need to give me any kind of definition. Just what you have understood from this graph. First draw the graph. Okay, before that watch the video properly. Okay, with time we will actually move towards some harder parts. Okay, if you only do the small simple parts, it is not going to work. Okay, you have to deal with harder parts. Okay, so maybe for some students it may be going to be a difficult question, but it is not actually a difficult question. You have to just understand the concept of the graphs. Okay, velocity time graph, position time graph, and acceleration time graph. First watch the video properly, then you will be able to give me the answer of this graph. Okay, in the next video, okay, I will actually announce the names of the winners as like that, and before that I will first give the answer of this question. Okay, clear? Now today I will end this video here. Okay, just watch the video properly. Again, I'm saying, okay, and then if you want notification of my channel, just subscribe to my channel, because lots of students are not actually subscribing. Views are getting 400 plus views, but still less students are subscribing. Just subscribe to this channel because it will help you getting the notifications. Okay, it is always beneficial. And if you just liking my way of teaching, just like the video too. Okay, it will give me some kind of encouragements, right? Always do that to any YouTuber if they are making a good and proper video, not only my video. Okay, there are lots of teachers are there. If they're making good videos than me, you should like them too. You should like me too, right? Give the thumbs up. Okay, so this is the thing about the motion part 4 video, where we actually understood the concept of graphical representation of motion, right? And okay, we'll meet in the next video. Okay, till then, bye bye.